We're here with John Hudson at TBS Studios in Atlanta, Georgia for the SMPTE meetings. John, how are you doing today?
Very well. How are you?
Excellent, excellent.
Good.
So, John, your role at Semtech, what do you do there exactly?
So I'm in charge of new product definition and international standardization for the Gen Products Group, and that's for all of the business. So it's not just our video products, it's also our datacom, physical layer products and retimers as well. So it's for all of the products that are in the Gen Products Group at Semtech Corporation. So we go everywhere from 400 gigabits per second all the way down to 100 megabits per second.
Nice.
I'm co-chair of 10E, which is the Essence Committee, which is responsible for any kind of essence, video essence, audio essence, even some data metadata that goes along with it.
Okay, so I want to talk about interface for a second,
Okay.
SDI. So what's the deal? Is the SDI interface on its way out? Is it dying?
So I think there will always be a need for an SDI-like interface, a real-time streaming media interface where you need to get bits or pixels from one place to another, in a very cost-effective, very low latency, very reliable way. And SDI has been the mainstream of the transition to digital for the broadcast industry for 20 plus years now. It's not going to go away anytime soon. Mm-hmm. And with the introduction of more and more IP networks, there will definitely be a transition, probably quite a long transition, where the two will coexist. What's really interesting is, with the higher frame rates and higher resolution images, that's driving bandwidths even higher for real-time streaming, which is adding a new lease of life even to SDI.
Excellent. So just as a basic thing, what is the difference between an electrical interface and an optical?
One goes over copper wires and one is light transferring over either a piece of glass or a piece of plastic.
Okay, and the difference between a single, a dual, and a quad link?
Okay, so going to multi-link interface is a way to increase the overall payload bandwidth without actually increasing the line rate. So for example, when we first started with HDSDI 7292, which was a single interface at 1.5 gig, when we wanted to do RGB444 processing, we needed some way to carry a payload which was twice that, which was 3 gigabits per second. And to do that, originally, we used two 1.5 gig links. Then, of course, as technology improved and prices came down, we introduced the 3 gig SDI standard. And the same process is continuing now with dual and quad 3 gig links to support ultra high definition. And now technology is becoming available to allow us to repurpose that coaxial based core infrastructure to move to 6 gigabit per second and 12 gigabit per second line rates. And in fact, even all the way to 24 gig using existing coax and connectors. So as technology's improved, we go through this process of introducing single links at higher rates. And in the interim, while it's a little more expensive to do that, we'll move to more links at a lower data rate. That's the way the industry's kind of always worked, and it seems to be a very pragmatic way for broadcasters to move to higher resolution images.
So there's a bandwidth disparity happening now with these higher resolution formats. How will the 3G interface accommodate these formats? So,
excuse me, the 3G interface will ultimately tap out in terms of what it's able to do. SMPTE's just completed its multi-link 3 gig interface standards. For example, SMPTE 425-5 is a quad 3 gig interface, and that carries up to UHD-TV1 or 4K D-Cinema production image formats up to P5060, i.e. it has a 12 gig payload. Of course we could go to 8 links at 3 gig or we could go to 16 links, but it becomes impractical.
Right. And
so 4 links at 3 gig is deemed kind of as far as you want to go on a multi-link interface. Hence why there's the new project in 32NF, the UHD SDI project, which is now looking at implementing 6 gig, 12 gig and 24 gig to take things on to those new requirements. Ultimately, the highest resolution, highest frame rate UHD TV2 format requires a 200 gig payload. And so there's quite a ways to go before you can get there in a cost-effective way. but it is technically feasible today.
So is there a clear advantage to using SDI over IP in terms of one technology over another? Are there limitations that IP has that SDI is clearly the winner on?
Well, really the big difference I would say is that it comes down to whether you want to repurpose existing broadcast infrastructure and workflows. Both have strengths and weaknesses in different applications, and I would say that on a workflow application basis, you should pick and choose the technology or the interface technology you want to use that's relevant to that. I would argue that today, there are quite a few problems that need to be resolved with IP networks if you want to do the kinds of things that are possible with SDI today. And so on a case-by-case basis, on an application basis, you should carefully consider your options in terms of interface.
Great. Thanks for your time, John. And you could find out more about the SDI 3G standards at standards.smte.org. Thanks, John.
Thank you.